So we're going to jump into lesson 10.1. So we just finished chapter 6, and we're actually going to jump all the way to lesson 10. And the reason we're going to do that is because we feel that this next unit really fits well with everything we were just doing. So there's no reason to wait. Let's jump right in so we can see the connection and use all the skills that you just had in chapter 6 right here in chapter 10 to help us solve systems. Now, this is one of the most important parts of algebra, something that you will see moving forward. You'll see it on the SAT. You're going to see it in all your math classes moving forward. You have to be able to solve a system of equations. It's one of the big key things that you have to have when you leave algebra is know how to do this. And you should have touched on this in middle school, mostly in Math 8. Okay, so this shouldn't seem completely new. But the big idea is we're going to solve a system of equation, and that means finding all the solutions that are common to the equations. Common means the same. So a system is a set, so meaning multiple, set of equations or inequalities, and they're joined by the word and, meaning that they all have to be true, that together describe a single situation. Okay, so two things have to be true at the same time. That's a system. So it's not just one specific equation that needs to be true. Two equations, both referring to the same situation, and a system is where both of them are true. So the solution to the system, we're going to write as an ordered pair, so like a coordinate point, or x and y, that satisfies both equations or inequalities. So if I take the x value and the y value that I get as my answer, and I plug it into both equations or both inequalities, it's going to make both of them true. So you could have two equations or two inequalities and find the solution to one of them. And every equation is going to have multiple solutions. If you think about a line, every point on that line is a solution to it. So every line, every equation has a ton of different solutions, but not all of them are going to match both equations in our system. So what we're going to do is try and find what's the point, or where are the multiple points that these equations kind of overlap, and that's what they're visually going to do on a graph. But where do they have, or where do they share the same solution? Where do they have the same point? And that's going to be the solution to our system. So system just means you've got multiple equations. The solution is going to be the one point, or it's possible to have multiple points where these overlap and they have the same numbers for x and for y. Now, it is possible that there's no solution, and we've talked about these types of situations before, but that is referred to sometimes as the empty set. So you're going to refer to your answers as a set of numbers, and so if it's an empty set, there's no numbers there because there's no solution. Or the null set, that's probably a new term. And when we write that no solution, that actually, technically, we call that the null set. Okay, and this is your empty set. So what this is kind of some brackets here. And traditionally, if there's an answer, the answers are going to be listed inside of these. They look like parentheses. And so if there's nothing inside of them, it's an empty set. There's no answers, or we write no solution, and this can be referred to as the null set. Now, there's multiple ways, like I kind of just dove into, of writing a solution here. So here's some of the various ways, and the way we're going to focus on the most is just your ordered pair. That's what we're going to do, but you can write it as an ordered pair identifying the variables. So just writing x comma y equals and then replacing it. Now, most of you would say, well, why would I write that extra part? Why can't I just write this? And you can. But just know that sometimes you'll see it written like this. You can also do it individually. So we know x is 14, y is 9. So you can actually write that out, x equals 14, y equals 9, instead of plugging into an ordered pair. And you can talk about the set of ordered pairs. Now, in this case, there's only one solution. So here's those brackets that you see. And inside are all the possible answers. Now, in this case, there's only one ordered pair in there. It is possible to have multiple ordered pairs. Okay, so that can change based on the situation. You can have a bunch of stuff inside that bracket. All right, we're going to look at example number 1. We're going to consider this system. So we've got two separate equations. We could come up with some numbers that we could plug into the first one. For instance, if you just plugged in 0 for x, you could find out what y is. Or if you plugged in 1 for x, you could find out what y is. If you plugged in 10 for x, you could find out what y is. And all of those ordered pairs that you're producing when you do that, those are all solutions to this equation, which would be on the line if you put it on the graph. But they're not all going to work here. So if I plugged in 0, I'd get 0, 0 minus 7 is negative 7. So the point 0, negative 7 works for this first one. But if I plug in 0 and negative 7 for x and y in the second equation, 0 goes here, 7 goes here, 2 times 7, I don't get 10. It does not work here. So the point 0, 7 is a solution for the first equation, but not the second. And what we're looking for is the ordered pair that solves both of these. And that's not always so easy to find. Okay, so what we're going to do first, before we talk about how do we do this by graphing it and finding the solution, we're just going to look at two different ordered pairs and test to see if they are solutions, because we need to make sure first and foremost that you understand what the solution actually means. So it's got to work for both of these equations. So we're going to verify that this ordered pair is a solution to this system. So that means we're going to take x equals 6 and y equals 11, and we're going to plug it into both of these equations, and we're going to see if it works in both of them. So starting with the first one, y equals 3x minus 7. I'm going to go ahead and plug in my 6 for the x and 11 for the y. So 11 equals 3 times 6 minus 7. So I'm going to get 18 minus 7. It's kind of like a check from back in the day. And you're going to get 11 equals 11. So 6, 11 is a solution to this equation. But is it a solution to the system of equations, which just means both of these equations? So now we need to go test it in the second one. And so we're going to take 2y minus 2x equals 10, and we're going to test it with the 6 and the 11. So 6 goes in for x, and 11 goes in for y. So 2 times 11, and 2 times 6. So I've got 22 minus 12 equals 10. I get 10 equals 10. And so this ordered pair of 6, 11 worked for the first equation. It also worked for the second equation. We got a true statement. So we have verified that this is true. So we can say, yes, 6, 11 is a solution to the system of equations. Six 11 is a solution to the system of equations. So on the flip side now, we're going to take a look at this one. We're going to show that 1, negative 4 is not a solution. So x equals 1, y equals negative 4. Show that this is not a solution. So we're going to go again right back to where we started using these two equations. So y equals 3x minus 7. And we're going to plug these in. 1 for x, negative 4 for y. I'm going to multiply, I get 3 minus 7. And I'm going to get negative 4 equals negative 4. So it worked right there. So 1, negative 4 is a solution to this equation. But is it a solution to the system of equations? We don't know that until we try it in the other equation and see if it works. So you can kind of guess that it's not going to work. So let's take a look. Plugging in 1 for x and negative 4 for y. We're going to get negative 8 minus 2. And what do we get? We're going to get negative 10 equals positive 10. Well, that's not a true statement. Okay, so we're going to say no. 1, negative 4 is not a solution to this system of equations. All right, and we will tackle how do we find the answer when given these two by graphing on the back, and you can go to the next video for that.